Greetings, Kerbinauts! This is Kerbal Space Program. I'm Bob Fitch, and this is episode number 6 of Project Ares. And in recent episodes, we've learned that Kerbin was forced to close their wormhole connection to Earth due to an unstable energy drain on their side. The Kerbals on Earth have heard nothing from Kerbin since then. They're continuing to advance their technology, which was the original plan, but now while also investigating how they might reopen the connection. There's an idea that studying the high gravity of Jupiter could lead to a scientific discovery about the wormhole, since we know the connection from Kerbin was linked to Eve's high gravity in some way. As far as launches, we have sent up 2 satellites to gather science data about Earth's gravity, magnetic field, and radiation belts. Katrina was recently sent to Mogadishu to inspect the second Sphinx launcher. The Sphinx you're watching right now was the first attempt from last episode that we're still finishing. It ends up being only a partial success, and today I'll explain how it went wrong. As far as the checklist goes, we're several episodes in now and still have not covered number 4, the formation of the Earth Union. So we'll get to that today as well. But first, this Sphinx launch. The intention for this mission was to make a launcher strong enough to reach the moon for a flyby, and a payload with science instruments to analyze the moon while we prepare for manned flights. The Kerbals are doing all the Delta V budget math by hand while helping the humans improve their computers so that they can do the calculations later automatically. Well, let me show you what they were doing. First, we need to know the formula used to determine your speed in an orbit. It's the square root of g, the gravitational constant, times m, the mass of the thing you're orbiting, times 2 over the radius at which you're orbiting minus 1 over the semi-major axis. G was calculated in 1798 by British chemist and physicist Henry Cavendish. He used a torsion balance that looked like this. There's 2 large lead balls and 2 small lead balls that apply a tiny amount of gravitational force on each other. He measured the angle change between the resting state and the presence of the lead balls. That angle difference gave him the force that was being applied, and using Newton's formula for gravity, he now had all the variables for the equation except g. So he just solved for g, and that's where we got it. And the force of gravity at sea level was calculated by Galileo by simply measuring it at sea level, which is, of course, roughly 9.8 meters per second. The radius of Earth was calculated by the Greek scholar Eratosthenes thousands of years ago. You may also know him as the guy who figured out how to calculate prime numbers. Well, he measured the lengths of some high noon shadows at different latitudes on Earth, and knowing how far apart those 2 places were, he was able to do some trigonometry and figure out what the radius was. So now we have all those, and given g, m, r, we just need A. So imagine we're starting in a circular orbit around 300 kilometers above Earth. And thanks to Galileo, we know that the radius is 6,371 kilometers, give or take. So the total is 6,671 kilometers. Now I'm going to make a spreadsheet so I can have a formula to automatically calculate this for me. To know your velocity in an ellipse, we're going to need to know the 2 ends of our orbit. You know, you have your apoapsis and your periapsis are the 2 ends of your elliptical orbit. Now in this case, we're saying, what if we were in a circular orbit 300 kilometers up? So I'm just going to put 300 in each of those. I'm going to add automatically the altitude, or the diameter, the radius of the Earth. So we're going to go 6,371,000 for kilometers of the apoapsis, and then do the same thing for the periapsis. So this will give the actual distance from the center of the Earth that the 2 points are. Now we need to know the velocity. This is going to come out in meters per second, so I'll put those right there. The semi-major axis is simply the average of the 2 values, the apoapsis and the periapsis. So that's what A is going to be. We also need the gravitational constant times the mass of Earth. That's a fixed value. It is that huge 3.9 blah blah whatever, so 3.99 to the e10 to the 14th. So we'll just put that in there. It's a fixed constant. It never changes for Earth, and so it'll be used for this formula every time we use it. And now we do the actual formula part. Remember I said that was the square root of gm times 2 divided by the radius. So to calculate the speed at our apoapsis, the radius is going to be the apoapsis, minus 1 over the semi-major axis. And we just finish out that formula. Now the exact same thing goes here, but in this case, it's going to be the GM times 2 over the periapsis, minus 1 over the semi-major axis. And we have that. Oh, let's fix that one mistake though. Up here, this is in 300 is the kilometers. Let's multiply by 1,000 to get that into meters and put that there. There we go. That's the value I expected. 7,730 meters per second in a circular orbit at both your apoapsis and periapsis. Now if I want to know how fast would we be going if we were in an orbit that went all the way up to the altitude of the moon, but at the periapsis was still down near Earth. In other words, we burn prograde at periapsis in order to raise our apoapsis. How fast would we be going at those 2 points? Well, now I just copy this section down here like I did and change the apoapsis to equal the kilometer distance from the Earth that the moon is. That is 384,400 kilometers. Make that a little bigger, and there we go. So now we know that at the altitude of the moon, we'd be traveling very slow, and down near Earth, we're traveling 10,840. Well, if we started off in a circular orbit, we were only going 7,730. So the difference between the 7,730 and the 10,840 is how much faster we need to be going. So down here, I'll do a little formula for that. We'll take that one, subtract that one, and that is how much faster we need to be going. So we'll need to apply 3,110 meters per second in order to achieve the velocity that we want to reach the moon. Now, how did I know that we had to go as far as 384,400? How do we measure that down on Earth? Well, that was another thing that the ancient Greeks did. By realizing that when something passes in front of something else, it casts a shadow, they were able to calculate how far away the moon was by doing some geometry math during an eclipse. I won't go into too many details about it, but suffice it to say that those Greeks were pretty genius and they figured it out. And this brings us back to the launch that wants to go to the moon, but it's not going to make it. First of all, there was a problem with the decoupling. The payload and the decoupler may have been intersecting a little because the way it pops off and tumbles, that's indicative of being poorly coupled. Speaking of payload, we haven't looked at that in the VAB yet. For the payload itself, we are powering this with UDMH and red fuming nitric acid. So of course that's what kind of engine this is down here, and that's the only thing on this section. In the next section up, you can see we have in the middle there a battery, 4 science computers, so this is capable of powering 4 science instruments. One of them is right here, one of them is over here, and at the top we have this one. And then over here on the side, we have a new instrument, which I have to fix up. Still says undefined, I gotta fix that. It's the material observation bay. In the top section up here, we have, of course, our solar panels. And in there, the main computer, lights all around it, batteries, science instrument, and then on this level, you can see that this is the one where we have attached our communications stuff, 2 communications computers in there, communications antenna. This one also has the gyroscope in order to maintain 2 gyroscopes. You can see one over there and one over there, in order to maintain our orientation to make sure that the satellite dish is pointing at the right target. And that's why we need these 2. And that will do it for the payload. So the first problem was the decoupling. The second is it's starting to seem like it has too little delta V to make it to the moon. And the payload has some fuel, but there's a third problem. Something goes wrong with the engine and it doesn't ignite. So now our payload is stuck floating in an eccentric orbit nowhere near the moon, but we still have a bunch of stuff on there we can test. Even though the overall mission was a failure, it's still a partial success because we can extend the new solar panels that have never been tried before and experiment with the strength of the gyroscope to see if it can easily orient us toward the sun for power and back toward the Earth again later for telescope observations. The material exposure bay has a bunch of stuff in it that we want to expose to space to see how they hold up, to see if Earth is similar to Kerbin. There are different types of metals that we might construct our ships out of, and different types of cloth that we might construct EVA suits out of. Over the next few weeks, the satellite will send back data about how well each material withstands space exposure around Earth. But ultimately, this mission was a failure, so we'll be launching again, but this time with even more technological improvements. Between every mission, all engines are going to be getting more powerful and more efficient. We'll also add some RCS to the payload for the next launch. While we watch the second Moon Intercept launch attempt here, let's talk about the Earth Union government. I promised I would do that earlier in this episode. In my alternate universe, the Earth Union was formed following a conference held in the Bilderberg Hotel of the Netherlands. Now, in real life, in 1954, about 10 years after my version of history, there was supposedly a secret meeting at the Bilderberg Hotel of the real Earth Netherlands. Many influential members of Europe and the United States were invited to this secret meeting where they talked about promoting cooperation between all European nations, the United States and Canada. They discussed politics, economics, and mutual defense. The meeting was such a success that everyone agreed they should meet once a year, and the location of the annual meeting has changed from city to city and country to country over the years, but the name, the Bilderberg Group, comes from that first meeting, even though they don't hold it there anymore. And they don't seek media attention or anything, and although journalists are sometimes invited, they are not invited as journalists. No reporting is allowed of what goes on. No one can quote anything that was said by anybody. That way members don't have to worry about being quoted out of context or whatnot. They are safe to freely voice their opinions in an open forum. Topics of interest have changed over the years. The first meeting was about post-World War II issues like communism and the Soviet Union, shared defense, post-war economics, and the dependence on imports. The most recent meeting, held in Dresden, Germany, was about China, the Middle East, Russia, US politics, cybersecurity, world economics, technology advances, and so on. So, in my alternate reality, the Bilderberg Group basically met 10 years before the real one did, and my group decided to actually form a new world government, unlike the real one. On real Earth, there are many conspiracies about the group, such as how they want to form a world government. There always seems to be conspiracies about any group that doesn't want to share whatever they're doing. Before I continue with my alternate Earth history lesson, I need to report a problem with the launch again. So far, it has gone well, though we went higher up than expected. We're coasting up to Apoapsis for a second ignition of the upper stage, and our RCS has oriented us toward our maneuver node. However, something goes wrong with the two small gimbal engines. We start the RCS to settle the propellants and fire up all the engines, but only the main engine starts, the little ones don't. This causes the RCS to try to hold our orientation, but the nitrogen in the tanks down below quickly runs out because we're not expecting to need all of that for pitch control. And after that, the stage starts tumbling. The problem turned out to be that the craft file had the old engines saved in it, even though I had updated those engines to now allow 2 starts. The fix was that I had to remove the old engines in the VAB and simply reattach the exact same ones, but new copies, and that brought the number of ignitions back up to 2. Unfortunately, this counts as another failure, so I need to launch this a third time. Fortunately, every mission is a month or 2 apart, and in between each one, I get to advance my tech a little bit more, so even failures are not total losses. Time still goes by for more advancements. Alright, let's go back to talking about the difference between the real Bilderberg Conference and my alternate Bilderberg Conference. In my alternate Earth, I figured it would make sense to actually have a world government come out of it following the discovery of Kerbals, because in all the movies and TV shows and books and everything about Earth facing a threat at a global scale, there's usually either a complete breakdown from lack of cooperation, or the opposite, a complete coordination and cooperation of all the nations. Well, I went with the latter idea, and incidentally, that was another reason that I formed the New World Government in Amsterdam. It was very close to the first meeting point in the Netherlands, as well as what I already said last time about the reconstruction efforts trying to rebuild Europe after World War II. Speaking of the war, that reminds me, Von Braun has been removed from my space program. In real life, Von Braun was a man who could get things done, and that sometimes rubbed people the wrong way. And remember, I had Sergei Korolev and Werner von Braun both in my space agency after the world government was formed. Sergei was another who could get things done, but both men wanted to run my space agency. Ultimately, it was decided that they would focus on different parts of the vehicle. Korolev would focus on the launcher, like the core stage, powerful engines and side boosters. Von Braun would focus on the upper stages, science instruments, fairings, payloads. Even with this division of labor, they argued a lot. And then, in the midst of all of that, some information started surfacing about von Braun's involvement in World War II, and how he may have treated some of his workers, or at least how he turned a blind eye to how some of his workers were being treated. More about that in a minute. First, I want to draw your attention to another error in our launch calculations. There's no remote tech link under the satellite where it needs to make its moon burn. That's no big deal. Instead, I fast forward a few orbits, let the Earth rotate until something is under where it wants to be when I want to make that burn. Okay, not a terrible problem. We can add that remote tech link to fix it. We can eventually have communication satellites in orbit. The real mistakes were error number 1, the payload still tumbles after decoupling, though we managed to get it under control with RCS. And error 2, the payload is a little unbalanced. The RCS tries to hold it steady, but once the nitrogen runs out, the payload tumbles. Once again, we're going to miss the moon. I'll no doubt be fixing these problems by 1, balancing the payload a little better, 2, redoing the engine to have a slight gimbal just in case it's still off-center a tiny bit, 3, adding another short-range remote tech link somewhere on the surface, maybe at an island somewhere in the ocean. Number 4, figure out why the payload decoupler likes to toss the satellite and fix it. Okay, back to Von Braun. The media and then the public started calling for an investigation. He made excuses like, I'd have been thrown in prison if I had not obeyed my orders. In real life, the United States needed his expertise for the space program, so this kind of stuff was overlooked. But in my alternate reality, since we have Von Braun and Korolev at the same time, Von Braun is not quite as crucial. He has therefore been removed from the agency and now looks to possibly stand trial for war crimes. Meanwhile, Sergei is taking over as the head of development, although we do have Von Braun's notes and plans. Korolev has reviewed them and agrees they show promise, so he'll probably still be following a lot of those plans, but without Von Braun around to help in case he needed any. So if things need to get changed, Korolev will need to organize those changes alone. And now we have a special report of some major news that was inevitable.
Good evening to all Earth Union nations. I'm Edward Murrow, reporting to you live from inside the Earth Union General Assembly. Delegates from around the world are arriving now to hear what we're told will be historic news. So far, we can only speculate what that will be. Nothing was more shocking than the formation of the Earth Union itself just 6 years ago. Since then, the Union
Well, folks, this is it. The humans are about to make the announcement. After today, they'll know we exist, and only tomorrow will reveal where this goes next.
And perhaps today...
And that's it for now. Our upper stage is making a stable low Earth orbit, then going around to its moon injection position. A successful startup of the upper stage for the second time, and the payload doesn't tumble as much after decoupling, and this time after opening the panels and beginning some spin stabilization using the persistent rotation mod, we fire up the satellite's engine and finally make a moon intercept that we can see next time. So until then, I will see you later, Kerbinauts.